So it's nice to be here. Thank you again for the invitation. And just to start about this this title about fair data and the research life cycle, fair data and software. I think really, what we're talking about is fair being applied in all aspects of the life cycle. I think sometimes people focus on particular aspects, and I think that really the whole effort behind FAIR is to try and improve machine readability and all throughout the life cycle. Another important point with FAIR is that it's a shared responsibility. Everyone in services need to work together to make it happen. It needs all of us to come together and make this happen. Especially open research too needs FAIR, and I think those are important points to make. But I'm interested in what is motivating you to learn about FAIR. And so one thing I wanted to do to start was actually see if you could open up this notes document. It's an Etherpad, a collaborative notes document that we use in the carpentries. I'll open it up right now, but I think we've also shared it in the chat, so hopefully everyone can access it. And I wanted to ask you what is motivating you to learn about FAIR, and if you could take some time, just briefly, about 3 minutes here, I think, just to maybe respond about what's drawing you into this session. So I'll pause here for a second. Thanks, everyone. And I should say that you don't have to log in. You could just start writing right away, and you can see that the collaborative document sort of highlights your answers. So data sharing is important in your work. We support FAIR and how to achieve it practically, yes. As far as the service goes. Public data is a vast resource for biomedical research, yes. I spoke with bioinformaticians recently, also talking about how they're hearing it from the NIH as well. So this NIH consortiums and need to collaborate with investigators is an important line. So I'm gonna jump back over to my slide. These are all really great answers. Thanks. So I will go back to my slides here, and I did. I thought about some of the motivations too, as well, and I thought, some of the things that might be drawing you. So research practices culture. In some ways, you might want to just do better science. That's one thing, and then research impact is maybe another. So discovery of your research, or help people sort of reuse your research. Institutional policies support. That's another one. If your institution is trying to adopt FAIR, and we heard some of that as far as practical approaches to getting started. Infrastructure and publishing. We heard about some services that are thinking about FAIR. Funders is really the big one. I feel like, that I hear from a lot of researchers, is I see it all the time in these calls or in other documents. And so I really want to know how I can be fair. And there's sort of legal aspects too to consider. And maybe you're just interested. That's another possibility. Thanks everyone for those answers. I just wanted to provide an brief outline of what I'll be covering in this talk today. So just a brief background on FAIR, just in case, maybe some of you have already heard this already, but just in case we can cover some of the background. And then FAIR principles more in depth, we'll be diving in a little bit into the principles. And understanding what FAIR means in your context, specifically in some ways assessment. FAIR examples is what is out there as far as what I can draw on for my own work, and then types of outputs or research software. I wanted to focus in on another type of output in FAIR, so research software, and communities to follow. So to start, the origins of FAIR. So it started actually not too long ago. If you think about it, it feels like it's longer these days. But 2014, a group got together in Lawrence, and really we're trying to break this habit of trapping data in the narrative in research articles. And they didn't want to be prescriptive. They wanted to. They didn't want to go down the standards path. Which sometimes can draw you in. And then they really did want to take this community-driven approach to creating machine actionable resources and FAIR resources, and really, free the information from these narrative articles. And they took this more lightweight approach, the guiding principles, which everyone has, of course, probably seen this. It's been cited 1,600 times and more, this FAIR guiding principles for scientific data management and stewardship. This has become like the de facto article for pointing to FAIR, to referencing it. But within that article, they really did, they broke down what, from Lawrence, they actually boiled down the work they did into these guiding principles, sort of 15 principles to help people as they moved along the sort of timeline of becoming more FAIR. Then if you go further, then Go FAIR picked up right after that and started creating resources. And they have a really good resource of sort of diving into these principles and understanding them more. But also Go FAIR looked at education, implementation, all this sort of networking work that needed to happen. As I mentioned before, this takes a lot of community work to move along that sort of FAIR timeline and improve. And then relatively recently, I think this also seems like a major point. The Denmark, the country of Denmark, put out a how-to FAIR guide, which I think went a bit further and addressed some of the things that not necessarily were addressed in the in this sort of initial principles. So adding a little bit more context. And I think one of the really more interesting things about that site is that you actually get to hear from other researchers and how they're applying FAIR in videos and their stories. So it's a very helpful resource. So I wanted to also do another breakout into the Etherpad and delve into those principles that we saw. You saw them listed, 15 of them. We can't address all of them, but I thought it would be good to delve into at least 2 of them. And so if you follow the link again to the Etherpad, hopefully it's shared again in the chat, or you have the slides, or you have it up already. And if we move over to the Etherpad, you'll see that the first question, F1, about metadata are assigned globally unique and persistent identifiers. And I wanted to ask you, so how in your, in your work, how you are responding to this this particular point, this principle. So if we take about 3 minutes, so if you could respond. These are great answers. The RID response is reminding me also to cover this a little bit later as well. So thank you. Yes, for the mapping of terms for in an ontology, that's a great response there. Doing what repositories are doing. Not sure how they would be defined as consistent. Yeah. And also, if when you're finished, you can also, I included another principle below. So R 1.3 metadata meets domain relevant community standards. So I don't know if you wanted to also respond to that. That would be helpful. Thanks, everyone, for contributing. Yeah, this is a great point about you may be responding to FAIR, but other services that you're using, because again, it's an ecosystem of services. You have to rely on other resources, and so yeah, it's a challenge at the moment. Just starting the ISCC service. What standards are available? Yeah, that's always a difficult too to understand what the standards are out there. So thank you, everyone. I'll flip back to my slides here, and I also try to answer these, answer some of these principles, which is some background. And so with persistent identifiers, what is the problem? Well, if you use a URL, standard URL, or, pointing to a website, it could go away and you could have a broken link. And one of the common ways to do this is what's called a DOI, digital object identifier, and you can see the anatomy of a DOI as far as the prefix goes. So that really responds to the suffix and other things like that, allow you to sort of parse through and see where this DOI is coming from, and along with their identifier. So that's a common way for publishing data these days. But there in general, there's many persistent identifiers, and I think that's one of the challenges too, that I've come across people trying to understand which ones they should use, or even how to get started to use one. And I think there was a recent paper from Perk or Percy. I don't know how any people pronounce it exactly, but it comes from the Globus group, which is a service for transferring, well, for sharing data, transferring data, large amounts of data. And they had this issue of sort of wrangling all the different identifiers. And one of the things they tackled, which I hear from researchers often, is I have been trying to get trying to mint my own DOIs, or with DataCite, or I'm trying to find like the right identifier to use. And in their case, I think they gravitated to something called minted, which they had more control over. But there are other persistent identifiers that you can take advantage of. And I think that this is a point to mention some of the other services that people mentioned in the sort of maybe the bioinformatics context of RRIDs. Or there's another service called identifiers.org, where you can actually see what identifiers are being used in sort of that bioinformatics context. But yeah, I think that this is a challenge, and I wanted to say you're not alone. There's actually a PID forum where you can go in and ask these questions if you're running up against this wall of like what identifiers can I use, what are good for my context, and there are a lot of experts in that community that can respond to you. The other thing is you have some agencies that are that are sort of helping with this to try and give some guidance on the right persistent identifiers to use. And JISC is one of them. They actually have had some recent meetings about sort of refining what are the important identifiers that are on their roadmap. And they've outlined 5 priority persistent identifiers. So ORCID for people, ROAR for institutions, funded grants, the Crossref grant ID, RAID is for projects, and that's relatively new too, and then DOIs for outputs. So on the metadata domain relevant community standards side of things, let me see if I can switch slides here. In general, metadata is sort of subset of documenting your research in a standardized, structured machine in a human readable way, to share it. And I always love this slide. The metadata is a love note to the future. It really is, helping others sort of reuse the work that you are producing. But we already have got some cases of where communities have really done great work of creating metadata standards. And the first resource I point to here is the Research Data Alliance has a resource of standards. In the bioinformatics context, Fair Sharing has done a substantial job in sort of documenting those standards. So that's also a helpful resource, or sort of discovering the standards that are in your community. And then here's an example of a study of Arctic climate, this project called Mosaic, which actually they do have a statement about FAIR, which I think is forward-looking of how they're trying to address it, communicating out to their community of how the recommendations of what they should be doing, which I think is a really good example of to draw from. And then a lot of these standards sort of build from overarching community standards. So this is not exhaustive, but I'll some of the ones that came to mind were the DDI, which are really started in the social sciences context, but has been extended in other places. And they're extending DDI for those other domains, disciplines. Dublin Core Metadata Initiative, something comes, it's something that the libraries actually follow to a good extent. Schema.org is something that, as far as the web world in general uses, started by Google and others. and DataCite is one that stems for what really was created for data, but is actually being used for sort of other research objects as well. And that that they also have sort of this minimal metadata that you can use that are used by repositories and around the world. Code meta is actually something more specific to software, as far as a standard that people are hoping you use for describing your research software. The thing is that when people are sort of pointing to FAIR resources and you point to these metadata initiatives, it's really hard for researchers in general to understand what they really what can they really use from this. It's really like throwing a lot of information, and unless you're like living in this constantly, then it's a lot of information. And I think that's why in our community we'll have to do a lot of work on sort of templates to really streamline this process and make it easy for people to submit this valuable metadata, to not see sort of all this underlying information. And Cedar is an example of that. Cedar creates some, again, maybe more from this bioinformatics side of things. Cedar is a templating tool that comes out of Stanford that has been used in sort of these biomedical cases. And I included some communities examples. Sometimes, there's these communities that, you can follow to help with understanding where standards are going, and trying to align with them. And the two that I pulled up, I spent 10 years in astronomy. One case that I thought of is the International Virtual Observatory Alliance, where a lot of those sort of discussions, including metadata, are happening. And the Global Alliance for Genomics Health, the GA4GH, is actually something we point to often in the Biodata Catalyst project as a resource. And then, there's the getting just your hands dirty and understanding how metadata works. And I'm not too sure too many services have this. I could be wrong here, but I do know of one that Zenodo has a sandbox where you can actually see what your record will look like before you publish, so you could test it out there, and you won't mint a DOI, you won't, publish it officially. You'll get to sort of test to see how everything looks, which I think is really helpful, because it can be a little nerve-wracking of publishing these data sets or other research objects. So understanding what FAIR means in your context, I think this is very important to take a step back. Sometimes you see FAIR and you start trying to understand. I think like trying to jump ahead and like try to look at examples. And I think it's really important to take a step back and think about what it means to you, because I think, again, this is a community effort and we're all sort of moving at different speeds, and it's really great to start at the sort of iterative approach of, here's where we're at and this is where we want to go. And I think assessment is a really great way to start, to see where you're at and where you might want to go. And this relatively recent tool called FairAware is a great way. It's I think it's more catered to the individuals, but you can maybe extend it to think about the institution or your service. But it's a question and answer type tool to help guide you through, giving you answers of, how you could maybe become more fair and understanding where you're at. Another resource is this, as far as more on assessment. So I'm working on a carpentry's lesson on FAIR, and it's maybe about 50-60% done. This particular module on assessment is a little bit further along. And so, it's not complete, but it still has some really great resources for you to look at for assessment. And one of those is one of the ones that I often refer people to, is the FAIR Zenodo principles. And the link is there. You can go to their main website and go to the footer and look at the principles that they have. And I often hear from researchers that this is fantastic. It's in plain English of how this service is trying to respond to FAIR. So I've often gotten great responses that, instead of having to delve into too much information, this is a great place to start. Other places to look at for sort of, understanding, assessing where you are, is repository checklist. I think we heard from some repositories on this call. And the one I show here is the open ear checklist of what researchers should look at when they're assessing repositories. So I think that's a helpful way to look at it. And then there's these other checklists. So this one by Sarah Jones through EUDAT, which is also very similar to the FAIR-AWARE, which walks you through sort of answering these general FAIR questions. I included something on the side too, which is reproducibility checklist. I know we're talking about FAIR, but it's really interesting in in my own context of how we're thinking of both like a reproducibility checklist, FAIR checklist, and how there's sometimes crossover between those. And this is one checklist that I particularly like from the newer IPS group, the machine learning group, which they've created of people sort of sharing their work before a conference, a popular conference. And then there's these FAQs and sort of guidelines, and I think the most notable one is COPDES, the Coalition of Publishing Data in Earth and Space Sciences. Notably, AGU has been sort of leading this effort, and they've got some FAQs and other information of sort of what criteria they're looking for in FAIR. If you really wanted to become serious about this, there is no FAIR certification at the moment. There are tools for testing for this stuff, but I think the de facto certification that a lot of repositories are using these days is called Core Trust Seal, and they have this requirements that they collect when when you're applying. And so that's another thing to sort of consider as you're putting together your repository. And they've done additional work on sort of what trustworthy digital repositories can do in addition, including governance, sustainable governance. And then to close here, another way to sort of assess is to look at your institution survey to see how ready you are for FAIR. And I pulled this FAIR in European Higher Education, FAIR is FAIR project, which did that sort of initial surveys to see where they might need to spend more time. Then there's examples. After you sort of do your assessment, is looking at examples. This is a common one that hear from researchers of sort of, do you have examples in this discipline or this domain? And I'd say at the moment it's still very hard to find these examples. There isn't sort of one curated set, and I in the Etherpad I actually included a section, if you still have it open, to include some of the examples that you particularly like around FAIR that you found really helpful. If you have time, please add them there in that Etherpad document. I won't go there at the moment. But I also, like through the carpentry's work that I've done in the past, we ran a global event to really speak to this, because there weren't any sort of discipline examples at the moment of people thinking about how FAIR could be applied. And so we took this top 10 FAIR data and software things approach of looking at, sort of trying to get it down into bite-sized information, what you really need to know about FAIR in these disciplines, and then exercises to help sort of help you see the practical side, the applied side. And we got close to about 20 of these different things. And another example here is coming from Germany. They ran a contest of who has the fairest data set in the land. And there are these examples that they found, and I couldn't track down the criteria that they used. Maybe they used one of these checklists, but I looked further into these resources, and I found additional things they could do to make their data more fair. So it'd be great to see what their criteria was, but I think the overall idea of these sort of awards, these competitions to see, what does a fair data set look like, are actually really good, at the moment, for us to have more examples. And then, there's more examples in sort of this EU report, this European Commission report, Turning Fair into Reality. That has a number of sort of practical examples, which I think is helpful as a resource for all of us, actually. And then I think again, another there are crossovers between FAIR and other things like data science, and this case doesn't speak to FAIR, but it's a favorite example of mine about the other aspects of FAIR that you need to look into is their culture and the training, because again, it involves people, and they're really going to help us move farther along, as opposed to this being more sort of infrastructure driven. And so that's a really good example of a team that started versioning their data and doing things that allowed them to be more efficient and share their resources in the ocean. I think the project is the Ocean Health Index. And again, we've paired FAIR training and carpentries, which has gone over really well. I think the first case was in TIB Hanover in 2018, 19, of a FAIR carpentries workshop, and I found that really inspiring. And I've done similar sessions where I think people really appreciate that combination, because it really helps them understand the context of why these skills are really these software and data skills are really important. So yeah, as I said, if you wanted to go over to the Etherpad and share additional examples, that would be great. I'd love to share those as well. Let me just take a peek. Oh, thank you, everyone. So we've got 2 examples there. That's really helpful. But if you have the time, please do go back and add anything. And then I mentioned I'd like to look at one particular sort of output I think that often gets missed. We're always talking about FAIR data, and software is very crucial, important to research as well. And so to start, I think we only started making waves in this area just recently too. I think this dates back to 2014, 2015, of where there was this we saw this trend in how software is being used, and particularly around the use of GitHub, and trying to fit within sort of the workflows of researchers and make their help them with making their software more citable, giving them DOIs, applying metadata for discoverability. So there's really the first attempt of working with a general repository called Zenodo and GitHub, sort of creating this release mechanism that could allow you to sort of publish your code in oh, sorry, hit a button there. Yeah, in sort of the scholarly communications way, the scholarly ecosystem way of doing things. Because before this, people were just sharing their GitHub URLs. And then just, maybe not so recent, but the next step here is the Software Heritage Library, which is archiving code in not just GitHub, but various places like GitLab and Bitbucket. And they're even looking at citing code at the at sort of code block level, and so that's a really great advancement in how we can sort of cite code and in research. But there are these resources out there, but one of the drawbacks is that it comes back to that sort of training element of, well, yeah, people are publishing the software, but they don't know how to relate it to all the other objects that are out there. And so you'll see a lot of software being published, but the related identifiers is something that's less used when people are publishing. And the related identifier allows you to connect it with your paper. So if you're looking up something in one of these systems and you haven't done this related identifier, you won't see the software. So this has been a challenge, I think, of, again, going back to sort of this interconnected ecosystem of where you may be doing something right, but others, will also have to do a certain way as well in order for this information to be part of that larger graph of data. This is relatively recent, the Towards Fair Principles for Research Software. It's a great resource, and we just had Anna-Lena Lamprecht speak at GoFair US to talk about her work, but it takes the principles and tries to relate them to what is meaningful to software, because there are slight variations, and it's a read. And also one of the more advanced things you can do is look at software quality checklists and management plans to help you sort of advance along this line of creating more descriptive, more discoverable software and other aspects of FAIR. And then there is the work of sort of refining that and making it so that focusing on the main points that you need to know, and again, coming back to the top 10 FAIR data and software things, there was a research software thing that actually gave 10 recommendations, and it made it into a poster at I think a bioinformatics event. Maybe some of the Elixir people, I can't remember exactly, presented it, but it were 10 recommendations to make your software FAIR, which is a great resource. But you can boil that down even further. And in the Netherlands, I believe the eScience Center has created this 5 recommendations for FAIR software, which is even simpler. Like, here are the major things that you should think about for making your FAIR software, and you can walk through it. It's a sort of a wizard tutorial. And again, the Netherlands eScience Center is one of my favorite examples of seeing how that can be applied, how it can become reality of a good example of like all the things being connected. And they have a research software directory that sort of connects all these different pieces. And so you can start seeing that product right there, the citation to the software, some additional metadata, connections with the repository to see how active it is. So it's a great example of where we could end up. But this is another interesting thing, which maybe we can discuss if there's time. But the papers with code and archive, a preprint server, decided to actually link archive preprints with GitHub. And this is stemming from the machine learning community. So what they did was mine the archive papers to find all the GitHub URLs, and then interconnect them. So when you're on archive or you're in papers with code, you can see both of these sort of interchangeably. And there's been additional work on sort of videos as well, which I find interesting. So creating this more dynamic research output. So I mentioned communities to follow. These are some of the the major ones that I thought of when I thought, if you're thinking about who you could follow to stay up to date with FAIR. Research Data Alliance, CoData, FAIR, GoFair, Force 11, STM Research Data Community. FAIR is a really good one that I follow because I think they're really just pushing the envelope for us. They're really moving things faster for us. And some of the tools that I showed are actually coming from them. Resources, I learn a lot from them. So I would highly recommend that one. But, you know, going back to CoData and Go Fair, they just recently ran a symposium where a lot of us were there to present and learn from each other, which is, you know, they're growing a big community of fair practitioners or teachers and you know, learners. So that this is if there's another one, that would be great. But in the meantime, you can go back and see some of the videos and slides and other resources. And I mentioned Go Fair US. We just launched as well, and started growing the community, and we have webinars at least to start, but we've started delving down into subgroup work, which I think we'll start with our next webinar on called Whips and Chips, works in progress and challenges that you might face. So we're encouraging people to submit sort of their ideas for feedback, and you know, some of those are forming subgroups, which is great. We're starting to move forward as far as a resource for the US. And I know this sounds funny, but Twitter is often a place where I get, and you know, you can see it from this example, researchers turn to other researchers on Twitter. So that's even an even bigger community of like how you could be more fair in your research. So that's a bigger community to look into. And last of all, another community is the FSCI, which is called this Fair Scholarly Communications Institute. It's a part of Force 11, and a lot of the material for this talk actually stems from a course that I have taught with Natasha Simons and Daniel Bangert and Fiona Murphy just recently. So this presentation is a slimmed down version. I encourage you to go and look at that, the resources we published there, the slide decks, because there's a whole lot more information that could be helpful. So we are on to the Q&A session, I think just in time. And sorry, I couldn't help it, but I included a Bernie name. So one of my favorites so far. So if we wanted to move to question and Q&A, that'll be good, but thank you.
Yeah, thank you. So you can unmute yourself and then ask question during this time. And then for quiz, there's some discussion in the chat. I don't know if you are able to see.
Yeah, I'm looking at it right now.
Yeah, it's along the talk, but most are comment or discussion.
Marianne added, you need to add our IDs. I mentioned it. So that was a borrowed slide from my colleague Natasha Simons. And I mentioned our ID. I realized it was missing. But yeah, good point.
Yeah, but you thought that it was a bioinformatics resource identifier, and it's really not. So
oh no, I mentioned that for identifiers.org. Sorry. Yeah, RID is not. Yes.
Okay, very good.
Just
checking. Because, you know, they really launched out of biomedicine, and biomedicine to many is just genomics, but that's, you know, biomedicine is much more diverse than that. In fact, vastly much more diverse than that. So there are efforts. I put some of them in your ThinkPad, just to know that there are a lot of groups, including dkNET, right, that are really working on FAIR in their own specific domains. And the research resource identifier really came out of the difficulty that biomedical researchers had in identifying what reagents and tools were used inside of papers. So it was actually launched in 2014, right around the time people were getting together in Leiden regarding the FAIR principles. So we just, you know, like to put a plug in for them.
Yeah, no, thank you. You just again, proving the point that this is a community effort. So
Exactly.
thanks for the additional information about RID. And there was a comment about code meta trying to fill in the fields. Yeah, I know there's sort of additional work going on to improve that. You know, it has been around for a while, and I think you know, there's some been some recent announcements about software citation. So, but I'm glad that you tried to try to apply it, Anita.
Yeah, thanks. No, it was at a workshop where there was it was a software repository and software registry workshop from, you know, the geosciences through biosciences and what have you. So like BioTools was there, we were there, and the astronomy registry was there. They actually headed it. Caltech was there and others. So what was really interesting to me, and the code meta people were of course there. What was really interesting to me is by the end of the day, when we looked at all of the fields that we were each capturing about software, there was just a really tiny number of fields that everybody was capturing, you know, about the code. And so it was just a really interesting exercise to try and map our, you know, repositories and registries to code meta specifically, because you know, I think there's still a lot of work that they have to do, the code meta folks, to make that a reasonable standard that's actually, you know, able to be followed by the code community. Because if the people who like register software every day can't do it, there's still some work to be done.
Yeah, you might not see this so documented well, but I was there in the early days when we were trying to do that early work with Zenodo and GitHub, and you know, the astronomy work is something, you know, on my way out, we put in that Sloan proposal for the work that they'd done to mine the data, right, to see if we could link this information together. And so you can see some of that work on Zenodo, but you're absolutely right. Like researchers don't know. I think, you know, as they're publishing their code on GitHub, there's sort of minimal information that you provide, and they don't know that that information could be invaluable when they publish. And I you know, I think that resource I referenced, the Zenodo sandbox, has been one that has been really successful for allowing researchers sort of to understand, you know, before they publish something, to play around and see how their research software will be published, you know, when they get around to it. So testing it out first. So I think that that's always a helpful resource. But, and you know, Arfon Smith, who was at the Space Telescope Science Institute, but was at GitHub before, who helped with all this stuff, he's back at GitHub as the science advisor. And so I know he was asking for advice on how to extend GitHub to help with this. But that is, again, just one place where people are publishing. But yeah, so probably more information than you wanted to know, Anita. But thanks. And I'm trying to get down further here. Share helpful, fair examples. Yes. Metadata is deposited. In our experience, only the most minimal of metadata is deposited in DataCite. Yes, that's also true. And then Dan Katz, you just had a article in Scholarly Kitchen, I think, that wraps up all this software citation information. So that's great that you added that link there. Yeah, I think I got into the end of the questions or comments. Are there any additional that I missed?
Yeah, you can also unmute yourself to join the discussion. And then I think some people add a fair example in the document, the carpentries.
Oh, okay.
Yeah.
Does
I have a
anyone
question.
Oh yeah, there's a question. Go ahead.
So I think you're saying that FAIR is something that has to be participatory, and people have to engage with it from the beginning. But it seems as if there is, in a sense, a lot of extra overhead, because you're adding more annotation, documentation, and you're building infrastructure around it. So even for people who do believe in kind of the benefits, the tenet of FAIR, I think the additional work makes a barrier that kind of prevents FAIR from, being more kind of widespread. So how could you address that?
Yeah, and there was a recent example from Research Data Alliance where they had some recommendations for services, particularly repositories, on how they could be more fair. And I think it got pushback because, again, those repositories that don't have the resources to maybe develop their services further. And so, yeah, I guess I can answer that to say that I get, it's a matter of time. And I think, you just plug away at it from different directions. So for instance, if you're trying to develop your services further, there's that community work, but also there's funding sources that will help you sort of develop your services forward. There are sort of underlying systems that these repositories use that maybe can incorporate some of these FAIR approaches. The cultural side, I think, is a really big one. The training side of getting the researchers also to start improving how they how they sort of link to data and other things like that. But I think that there's just challenges all over the place, and it is going to take time. I think from the publisher's perspective, they're still struggling to get data citations or software citations through in the XML in their underlying sort of metadata to be able to sort of leverage in their systems. And I think that's that definitely hearing that from publishers as well as sort of the work that they have to sort of invest in to do that. So it's a lot of investment from different, also the investment side of sort of agreeing, because I mentioned too that I come from more of an astronomy background. For 10 years. I spent some time there, and they had very few standards. and whenever I went to sort of big data workshops or data science workshops, FAIR workshops, then you sort of get exposed to all the different metadata standards that other domains are sort of struggling with, where you have sort of all these smaller communities developing their own standards. And there's an XK.
So
yeah,
that
sorry.
actually reminds me, there's an XKCD. The standards one. So specifically, when you talk about FAIR to someone who's new, like what % of people are going to go and want to implement it?
Are you talking from the repository perspective or the individual researcher?
From the researcher perspective, because I think in order to engage them, exactly. I mean, it's kind of fundamental, right? But it's really difficult to do so.
It is, and I'm sorry, Chris, I'll turn it over to you in a minute. But one of the things that we're really focusing on at dkNET because of this is data management in the laboratory, where to say that what the researcher needs to be concerned about is data management in the laboratory, and FAIR sort of starts with good practices that are of a benefit to you to running the laboratory itself. I love your little metadata is a love note to the future. It's the same way when you annotate data in your lab, it's a love note to your colleagues and your PI and everyone else. So I think my feeling about it is I do very much agree it's a partnership, but that the things that the researchers need to focus on are not the persistent identifiers, and those they get when they put it into a repository that's FAIR. So the repositories take a certain amount of the burden, and that what the researchers have to do is really think about managing their data appropriately for reuse. then that includes their future selves and also all of their other lab colleagues. I do really believe you have to break it down and meet people where they live.
I'll just add that I did talk to a number of our fellows in Biodata Catalyst before I gave this talk about FAIR, and checklists really resonate with them. They you know, particularly, again, they really appreciated the sort of Zenodo principles in plain English of like how, you know, this can be applied. Because they're also fellows, they work on services, you know, they're doing research, but they were also working on services. So they kept getting this information from the NIH and other sources of like, you need to make your research more fair. And they couldn't find any sort of practical information to get started with. And so that seemed to resonate. And another place where I've seen it resonate is, again, back to the sort of data science training that I've done in the carpentry is aligned with FAIR to see it in context as well. I've seen, in fact, the TIB Hanover FAIR workshop was really interesting to see. You know, I thought researchers had come to the workshop for the skills training for carpentries, but they all across the table said they came for FAIR, and that, you know, again, seeing it in context was really helpful because they felt the pressure, and that was from Europe. You know, that's not necessarily from the US. But they felt the pressure from the funding agencies. So
well, it's funny that you mentioned NIH, because the kinds of things that they are expecting from every single grant are the things that RIDs cover. So what they're expecting is that there's a document that states exactly how to authenticate, and this is in dkNET. There's a whole section on authenticating your research resources. The NIH specifically spells out antibodies, cell lines, and transgenic organisms as their kind of top 3 things that biomedical researchers need to be concerned about. And of course, all of those have RIDs. We actually have some documents on dkNET to help investigators create their authentication key resource authentication document, which COA has put together. And you know, those are really practical things. It's like, is your antibody working the way you think it's supposed to be working? I mean, I know that antibodies are very far away from physics and astronomy, but those are the kind of practical things that biomedical researchers actually need. And so I would encourage you to take a look at those, because for biological researchers, those things are going to be much more hands-on than looking at how fair a particular repository is compared to so just
yeah, actually I'll include this resource because I will speak to Research Triangle Institute in a week and they've been asking these questions. So I did look at dkNET, but I'll look a little bit further. Thanks for the suggestion.
Well, thank you for the excellent talk. It was very, very helpful, and I learned a lot of new things.
Well, I hope so. I think I learned from you guys as well. That's what always happens, I think, because exactly. I think we always have different pieces of FAIR.
Exactly. It is a community indeed.
It is. So thank you very much.
Yeah.
Yeah, thank you.